Finally, let's count some poker hands. This is a very popular this is a very popular type of question. People are very interested in poker hands. Let's go through some of the skills that you can learn so you can count any kind of card deck situations. Okay, so we've got a standard deck of 52 cards. I've got 4 suits and 13 denominations. Okay, so you should be familiar with a deck of cards. Let's start off easy. What is the probability that if we are given 5 cards, what is the probability that 4 of those cards are diamonds? Okay, so here I've done part A. Out of the 13 denominations, that's ace through king, I need to choose 4 of them, any 4, I don't care which of them. So out of the 13, choose 4. Out of the 39 non-diamond cards, I will choose 1. Sorry, I said denominations. Out of the 13 diamonds, I need to have 4. Out of the 39 non-diamonds, I need to have 1. Out of the total 52 cards, I will choose 5. You can calculate that to find the answer. What's the probability that someone observes 4 of a kind? Okay, in this case, I'll say 4 of a kind, just meaning 4 cards of the same denomination, and then I'll do the 4 of the kind in the poker sense. Okay, so here I just wrote myself a little key that's all 4 being the same suit and then a missing suit. So let's first, out of the 4 suits, we'll choose one of them to be the matching suit. So there are 4 suits to choose from. Choose one of them to be the matching. Out of the 13 denominations inside that one matching suit, we need to choose 4 cards. Okay, so this will account for the matching either 4 hearts, 4 diamonds, 4 spades, or 4 clubs. Finally, we need to choose the one non-matching. Okay, so out of the 3 remaining suits, we need to choose one of them to be our non-match. And out of the 13 possibilities in that one non-matching suit, we need to choose 1 card. So that's 3 choose 1 and 13 choose 1 in the numerator. We multiply all of these together. Out of a total of 52, choose 5. For 4 of a kind in the poker sense, which means that I get 4 aces or 4 kings or something like that, you can see how this works. Let's first choose the matching denomination. Out of the 13 denominations, that's ace through king, let's choose one of them to be our match. 13 choose 1. Out of the 4 possibilities, we've got 4 kings, 4 aces. We need to have all 4 of them if we're going to have the 4 of the kind. So out of the 4 possible, let's choose all 4 of them. Then we've got 12 remaining denominations. Okay, we don't want to include the one we've already talked about as the matching. So we need to choose one of the remaining 12 as the non-matching denomination. And then there are 4 of any particular one of those. We need to choose one of them. For 13 choose 1 times 4 choose 4 times 12 choose 1 times 4 choose 1. Out of 52, we are choosing 5. Okay, if we just want to find the probability of a single pair, okay, so that's just 2 matching cards, 2 matching denominations, and the rest are singles. That's pretty simple to do now that you're starting to understand what the patterns are. Out of the 13 denominations, let's choose one of them to be our matching denomination. 13 choose 1. Out of the 4 possibilities, there are 4 kings, for example. Let's say we need to have 2 of those kings. So out of the 4 kings, let's grab 2 of them. Let's talk about the non-matching denominations. Out of the 12 remaining, we need to choose 3 of them for B, C, and D here. Okay, so out of the 12, we'll choose 3 non-matching denominations. And for those to be all singles, let's have 4 choose 1, 4 choose 1, 4 choose 1. Or you could replace this with 4 choose 1 to the power 3. Out of all 52 cards, we are choosing 5. What about 2 pair? Okay, so 2 pairs here and then a single. The matching denominations, out of the 13, we will choose 2 of them to be matching. So that's AA and BB. So out of the 13, we'll choose 2. Of course, out of the 4 denominations themselves, we need to choose the 2 matching. So 4 choose 2. I'm also missing here a 4 choose 2 as well. This should be 4 choose 2 to the power 2, seeing as I need 4 choose 2 once here and 4 choose 2 also here. Sorry for that typo. I should have another 4 choose 2 here, or a power 2 right there. Okay, out of the non-matching denominations, there are only 11 denominations to choose from. It should be 11, choose 1 for this C. Okay, so out of that, it needs a single. That's 4, choose 1. Out of the 52, choose 5. Again, my apologies for the typo here. There should be a 2 up to the power 2 here. This 4, choose 2 to the power 2. Okay, what about a full house? That is 3 of a kind as well as a pair. Okay, so out of, let's do the matching denominations here, the triple matching denomination. Out of the 13 denominations, choose 1. Out of the 4 cards, choose 3. Out of the double denomination, let's do 12, choose 1. And here, out of the 4, choose 2. Okay, so that's for a full house or a triple as well as a pair. A simple triple then will just be 3 reps as well as 2 singles. Simply, I've got here 13, choose 1 for the denomination of the triple matching, and of the 4 cards, I need to have 3 of them. And then for the non-matching denominations, there are 12 remaining, choose 2 of them to be the singles. Okay, and that is some of the patterns for counting poker hands.